So we want to start working out our equations. We want to start solving. We've got lots of equations and lots of unknowns. Right now we know the potential across A and B, and we know the current through this resistor. Let's start working it out. The first thing I notice are these two equations right here. From this equation, we see that I6 and I7 must be the same. So let's add that note right here. So I6 equals I7. There's one equation we can use. We're going to start substituting these into previous expressions to get things worked out. If we look at this guy, we can solve for current I6 in terms of current I5. So let's do that guy for this equation. So this says that 45 times I5 equals 60 times I6. Which means that current I6 is going to be 45 over 60 times current I5. 45 over 60, that's 0.75 I5. Okay, so now there's a couple of pieces of information we have, and we know, of course, since 6 and 7 are the same, 7 is also going to be 0.7 times I5. So let's take these two guys and let's put them in this equation right here. And this is going to start to simplify because we're going to start to be able to working out our different currents. So let's do that next. Let's write down this current law equation. I2 equals I5 plus I6 plus I7. Now let's fill in what we know. So current I5, let's just call that I5 for a moment. Current I6 is equal to 0.75 times I5. Current 7 is the same as current 6, so plus 0.75 I5 again. Add those guys up, and what this tells us is that current I2 is equal to 2.5 times current I5. And if we wanted to write that in terms of I2, it means that current I5 is equal to 0.4 times current I2. So there's another result we have. Let's use this expression, or let's now go to loop number 2. So let's look at this loop and see what we can say about I3 and I4. Oh, let's come here. Let's see what we can say about I2 and I3. And then we'll use something from loop 2 in this one as well. Yeah, so that's where we're going to go next. We see that I2, we figured out something about I2 right here. See that I2 is I3 plus I4. If we come down here, we've got a relationship between I3 and I4. So let's start to put those two guys together. So if we come to this one, 40 times I3 equals 60 times I4. So it means that I4 is going to be 40 divided by 60 times I3, or 2/3 I3, 0.67 times I3. So now we can take this and put this together with this current law equation. Let's do that one next. So I2 equals I3 plus I4. So we have I3, and what we just figured out was that I4 was 2/3 of I3. So that's equal to 1 plus 2/3 is 3/3 plus 2/3, 5 over 3 times I3. So this means that I3 must be 3 over 5 times I2, or 0.6 times I2. Okay, there's another piece of information that we have. So let's start to put this together. If we look at loop number 1, that's got current 1 in it, it's got current 5 in it, and current 3 in it. Currents 3 and 5 are related to current 2. Current 1 is something we know, so let's put these guys together and it'll give us current I2. So let's go with the loop 1 equation. We'll write that down again. Minus 21 times I1 plus 45 times I5 plus 40 times I3 equals 0. Now we can solve this guy. So let's plug in what we know about I5 and I3. So minus 21 times that's a little bit of a mess. Minus 21 times I1 plus 45 times I5, but I5 is 0.4 times I2. Plus 40 times I3, but I3 is 0.6 times I2. Equals 0. So put these two expressions together. What we get here is that minus 21 times I1 plus 42 times I2 equals 0. So I2 is going to equal 21 divided by 24, or 42 times I1. We put in our I1 that we found, 0.4286 amps. And we get current I2 is equal to 0.2143 amps. Okay, so now we know currents I1 and I2. Now that we know current I2, finding currents I3 and I5 are going to be really simple. So let's do those next. So current I3 equals 0.6 times current I2. 0.1286 amps. Then current I4, what did we say about current I4? We said that current I4 was 2/3 of current I3. Let's use that expression and find I4. That's 0.08572 amps. Let's do current I5 next. So what we said about current I5 was it was 0.4 times current I2. So then current I5 is 0.08572 amps. And what do we have left? Current I6, let's get that one next. What we know is that current I6 is 0.75 times current I5. So current I6 is 0.06429 amps. Last current is current I7. What we know about current I7 is that I7 is equal to I6. So now we have found all the currents through every resistor using Kirchhoff's laws. If you check this against what we did use in the equivalent resistance method, then you would see that those guys were equal.